Hello and welcome to this episode of Packet Tracer. In this episode, we want to talk about the simulation mode. In simulation mode, the network takes a slower pace and you can observe the paths that the packets take and you can inspect those packets in more details. When you switch to the simulation mode, the simulation panel starts to appear. Let me drag off simulation panel from here so that I can have better view of the simulation panel. Then I can graphically add ping packets or ping PDUs by clicking this button in here, add simple PDU, and then pressing on the PC0 and then to the server 0, and now a ping packet is created. Now I can start the simulation mode by pressing the auto capture or play button, and once I play it, the simulation starts to happen. I can control the speed of the simulation by dragging this slider to here for slower pace or by dragging this slider to here for a faster pace. I can also click the play button once again to pause the simulation. The event list records all of the PDUs that propagate through the network, and it also allows you to inspect those packets at a later time for more detail. You also have the ability or the control to manually go forward or go backward in your own pace, and this way you have a manual control over the pace of the network, and in fact you can go forward in time and backward in time to inspect the packets in more details. If you click reset simulation, the event list will be cleared and the simulation will be restarted. Please note that while a simulation is playing, you may see packets that you did not create yourself. This is because some devices generate their own packets, such as ARP packets, as the network runs, and this is just a requirement of the network. Let me power cycle the devices, and then the ARP packets start to appear once again. Even though we didn't create the ARP packets are there because of the requirements of the network and because some packets are automatically generated by the devices themselves. Here in the type field of the event list, you can find out what type of packets are being propagated across the network, such as ARP packets, ICMP packets. You can choose to view certain packets or filter certain packets by going to edit filters, and then from here, based on the protocols, you can add or remove the view of certain packets. For example, I don't want to see ICMP packets anymore. Now I have removed ICMP packets from the filter, and even though I create an ICMP packet from this computer to this computer, but you cannot see the ICMP packets because it's not included in the filters. You can show all of the filters at once, or you can remove them all at once. Now I have removed all of the filters, and now I can selectively choose between these protocols, or I can show all of them and then maybe remove some of them in between. Here in the filters, you also have the ability to create ACL filters, and based on the ACL filters, for example, deny, IP, any. This is just an example of an ACL. I can filter packets that are shown in the simulation panel based on the ACL filters. So that in here you can add your own customized IP addresses based on the source and destination of the packets that are traveling across the network, and it's very useful indeed. You can also hide the simulation panel by clicking the event list, and the simulation panel will disappear for you. You can bring it back by clicking the event list once again. That's it for this episode, everyone. I hope this has been informative for you. Please like, comment, and subscribe, and I hope to see you in the next episode. Stay tuned. Hello and welcome to this episode of Packet Tracer. In this episode, we want to talk about the event list and the time flow of events. As you can see, here I am in the simulation mode and we have the event list opened. Packet tracer simulations do not run on a linear time scale. As you can see, the time is not running at all at the moment because time is determined by the events that occur in the network. An event can be defined as any instance of a PDU that is generated in the network. And the event list will keep track of all of such PDU instances and lists their information in various different fields. For example, let me play this simulation so that some packets are generated. As you can see, the packets are generated. Let me pause it and try to explain to you what are these fields. The visible field shows you which packets are visible at this moment on the network. As you can see, we have two visible packets. One is this one and the other is this one, and that's why they have the visible field on. The time field indicates the time in seconds in which the event has occurred, and this is relative to the last time the simulation scenario was restarted. This field is also the simulation time index. The last device indicates the previous location of the packet. The at device indicates the current location of the packet, and the type field indicates the packet type. For example, EIGRP, STP, ICMP, and different type of protocols. And if I try to click on one of these packets, this info, the PDU information will open and it will show me more details about this PDU, and this information is broken up into each layer of the OSI model. Let's play this simulation once again. As you can see, some events occur very frequently and they might be happening every few milliseconds. Some other events occur very infrequently, happening every minute or so. As you can see, most of the STP packets in this network are running quite frequently, about 1 second apart from each other. Now we have the DTP packets, which are happening infrequently, and probably the time difference between each packet could be around 15 seconds. On the simulation mode, network events appear to happen one after another at the same speed that is set by the slider. But in reality, they might be separated by milliseconds or even by minutes. You can keep track of the event timing by looking at the time field of the event list. Time only advances when there is an event to be occurred. If the network has no events or no packets, time will essentially halt until the next event occurs. This is called the auto capture indicator, and it will tell you where the event list stopped recording the last time. This constant delay option enforces a constant delay of 1 milliseconds between each event. And if this option is off, various factors will contribute to the overall delay of the events. If you filter out some of the PDU types in the PDU filter list, for example, let me select STP if I can find it. Now STP is removed, and as you can see, we cannot see STP on the event list anymore, and the simulation might run more quickly because you don't see the unfilled events. But all of the events are still captured in the network and are still available. And if I try to turn on that filter once again, the packets will start appearing once again, even though they were not captured in the first place. That's it for this episode, everyone. I hope this has been informative for you, and I would like to see you in the next episode. Stay tuned. Hello and welcome to this episode of Packet Tracer. In this episode, we want to talk about restarting a scenario, or whenever we want to restart a simulation. Whenever we want to restart a simulation, the simulation time resets to 0 and the event list is cleared. So let's go to the simulation mode so I can show you how it works. You can see that this is the simulation panel, and whenever we want to reset the simulation, the event list will be cleared and time will be reset to 0 once again. Let's generate some traffic and populate the event list. As you can see, some traffic is generated and the event list is populated. Now I want to reset the simulation. The first way to do that is to press this button. Once I press this button, the simulation is restarted. Another way to do that is to power cycle the devices. If I also power cycle the devices, as you can see, the simulation restarts once again. The third way to reset the simulation is that if I switch between real-time mode and simulation mode, now as you can see that the event list is cleared once again. The fourth way is that if I try to bring some type of changes to the topology or to the network that I'm working on. Now if I try to add a router in here and delete this router, now as you can see the event list is cleared once again. The next way to reset a simulation is that if I change to another scenario here in the simulation mode. So this is scenario 0, the default scenario. Let's just populate first. If I try to create another scenario, scenario 1, now the simulation panel is restarted and the event list is cleared. Now even if I go to scenario 0, you can still see that the event list is cleared. Another way to reset a simulation is that if I try to delete a PDU here from the PDU list window. So let's populate some traffic once again. Go to the PDU list window. Okay, now I want to create a PDU from PC0 to switch 0. As you can see, the PDU is created and it appears on the PDU list window. If I try to delete one of the PDUs in here, now let me delete it. As you can see, the simulation panel is restarted once again. So the way that you delete the PDU is that, let me show you once again. If I go to PC0 to switch 0, double click here under the delete column, the PDU is deleted and the simulation panel is restarted once again. That's it for this episode, everyone. I hope this has been informative for you and I would like to see you in the next episode. Stay tuned. Hello and welcome to this episode of Packet Tracer. In this episode, we want to talk about sending simple PDUs from one device to another and how we can add simple PDUs in a quick graphical way to send one-shot pings from one device to another. So before you're able to send a PDU from one device to another, you need to make sure to have at least one of the ports configured with an IP address here in PC0 and also on switch 0. So I have configured these two devices with these two IP addresses, and now we will be able to send PDU packets. So to send a PDU from PC0 to switch 0, first I will click on PC0 and then I will click on switch 0. Of course, when I have clicked on this button, which is the add simple PDU, because when I click on the Add Simple PDU, my cursor changes to PDU, and now I can click on PC0 and again on switch 0, and 2 packets have been created, as you can see. Once you have created the request, the source device will queue an ICMP and also an R packet depending how the network is configured. And both of these packets will be on queue until you press the play button or you move forward the simulation. Now, as you can see, I'm moving forward the simulation and the devices are being played and the time is going forward. And I will be able to observe the ping process. If I don't want to be confused, then I can always edit the filters and maybe remove some of the protocols from the filter. For example, maybe I would like to remove STP, then I can always do that. STP. As you can see, the STP packets are now removed and I can only see the ICMP and R packets. You can also keep track of all of the PDUs you have created here in the PDU list window. So this is the PDU list window. As you can see, my pings have failed. I'm not sure why the pings have failed, but as you can see, they have failed. The PDU list window is originally located in here. So if I toggle, as you can see, it goes to here. And if I toggle once again, it comes to here for a better view. That's it for this episode, everyone. I hope this has been informative for you, and I would like to see you in the next episode. Stay tuned. Hello and welcome to this episode of Packet Tracer. In this episode, I want to explain the quality of service stamps that are some visual indicators in simulation mode when you have the type of service or the differentiated services field in the IP header enabled. So let's get started and see how it works. Here I am in the simulation mode. I want to create a ping packet from PC0 to PC1, and I want that ping packet to have the TOS or the differentiated services field enabled. Let's go to traffic generator. I have my destination IP address here, the source IP address here, and as you can see, the type of service. I have enabled this field and I have given it a value of 6. Now if I send the ping packets, you will be able to see that small black stamp, that is the quality of service stamp. And if I try to send the ping packet, you can see that the ping packets are sent. Now let's investigate the ping packet. You will be able to see that in the outbound PDU, the ping packet has the DSCP value of 1 enabled. It is 1, it means that the quality of service is enabled. If the quality of service is not showing up, you need to make sure to go to the preferences, and in the preferences you have to make sure that the show quality of service stamps on packets, this preference is enabled. You can always find about the color coding here in the help. Go to the content, and once you go to the content, come here in the simulation mode and scroll down, and in here quality of service stamps, you will be able to find all of the color codings about different type of quality of service stamps. That's it for this episode, everyone. I hope this has been informative for you, and I would like to see you in the next episode. Stay tuned. Hello and welcome to this episode of Packet Tracer. In this episode, we want to talk about the PDU information window in the simulation mode. So let's get started. Let me create a ping packet from PC0 to PC1 so that a ICMP packet is created and we can inspect the PDU information window. So as you can see, during a simulation, we can click on this packet and the PDU information window will appear for us. This PDU information window could possibly have 3 tabs for us. In this packet we have 2 tabs, but if we go ahead, in this packet we still have 2 tabs. Now in this packet I think we have 3 tabs, and this is the 3 possible tabs that we can have in in PDU information window: the OSI model, the inbound PDU details, and the outbound PDU details. Here in the OSI model tab, it is shown to us how this packet is processed at each layer of the OSI model by the device that this packet is currently located at. So this packet is currently at PC1, and it's showing us how this packet is being processed by PC1 in terms of OSI model. And this process is further separated by the directions of inbound and outbound directions. In the in layer or incoming layers, it is shown to us how this packet is being processed by this device, and we are meant to start reading the in layers from bottom to top. And in the outbound layer, we can find out the process that this packet goes through when the device is sending this packet from one or its multiple ports. And we are meant to read the out layers from layer 7 to layer 1, from top to bottom. The inbound PDU detail tab is only applicable if this packet is being received on this device. And this tab shows us what is in the headers of the PDU of this packet, and it has broken up the PDU into multiple headers of Ethernet and IP address and TCP and ICMP, of course, in this packet, and other pertinent information. The outbound PDU details tab is only applicable if the device has a packet to send, and it is also showing us similar information to the inbound PDU details, including the headers of different protocols, including Ethernet and IP and ICMP. And as you can notice, most of the time when a device receives a PDU and as a result it wants to send out a PDU, then both the outbound and the inbound tabs apply. But if we only have a device that is sending a packet, then only the outbound PDU detail tab is applicable. Or if a device is receiving a packet and there's no need to process and send a packet in response to this packet, then only the outbound PDU detail tab is applicable. Here in the PDU details window, we also have this challenge me pod, which if I click this challenge me pod, I will be quizzed on the process of encapsulation. And there is some questions and quizzes that I need to complete for my understanding of encapsulation process. So let's try this out. So as you can see, I have been given a question. What is the device? Let's go to the hint and see what hint Packet Tracer is trying to give us. Fast Ethernet receives the frame. That's it for this episode, everyone. I hope this has been informative for you, and I would like to see you in the next episode. Stay tuned. Hello and welcome to this episode of Packet Tracer. In this episode, I want to talk about PDU color legends. So as you can see here in the simulation panel, every type of different packet, they have their own color scheme. So let me fast forward this simulation so that more different type of traffic is created. As you can see, ARP has its own color, STP has its own color, ICMP has its own color, and let's go, maybe there will be some DTP packets as well. Yeah, CDP packets, DTP packets, each one of them, they have their own coloring. And if you want to know more about this coloring, what you can do is that to come to the help here, go to the contents. Now you have this page, and then go to here, PDU color legend. Then you will be able to find a reference page for all of these colors that are used in the simulation panel. That's it for this episode, everyone. I hope this has been informative for you, and I would like to see you in the next episode. Stay tuned. Hello and welcome to this episode of Packet Tracer. In this episode, we want to talk about simulation mode, and in simulation mode, we want to talk about managing simulation scenarios. In Packet Tracer, you can set up and simulate complex networking situations through the user-created packet window found in here. A scenario is a set of PDUs that you have placed in the network to be sent at specific times. When you first switch to simulation mode, the default scenario is scenario 0. You can edit the name of the scenario, or you can write a description for the scenario by clicking here. Let's write the description. This is my scenario with pings. And you can also edit the name of the scenario. My scenario. You can create new scenarios or delete scenarios. So this is a new scenario. This was the default scenario, which I renamed. This is a new scenario, or I can now delete my old scenario. Here I am in this scenario with my description and I want to delete it. So now I can delete it. Now the default one for me is scenario 1. So basically, the purpose of creating multiple scenarios is that you can create one topology, but you can test different conditions for this one model that you have created. Please note that there is a difference between the packets that are shown in here, which is the user-created packet window, and the packets that are showing in here, which is the event list. The event list is basically all packets occurring anywhere on the network that you have chosen to display, and they were not necessarily originated by you or by protocols that are running on the network device. But of course, the user-created packet window is exactly the packets that you have created for your own. The PDU list is an important part of the user-created packet window that tracks all of the PDUs that you have created for your scenarios. Let's just create a PDU first so you can see that how the PDUs are created and how you can see them here in the PDU list. If you want a better view for the PDU list, then you can toggle the PDU list window and the PDU list will appear in here for you for a better view, and more details are shown now. The fire field is to send the PDU immediately in real-time mode or queue for transmission in simulation mode. The last status indicates the last known status of the PDU. It could be successful, it could be a failure, or it could be in progress. The source shows the name of the device which the PDU was originated. The destination shows the name of the device that the PDU is ultimately trying to go. The type specifies the PDU protocol type. It could be ICMP, CDP, DTP, FTP, SNMP, and many protocols as such. The color field shows the PDU color as it appears in the animation, and we can change it, of course. The time field displays the simulation time or time frame at which the PDU is scheduled to be sent. The period field indicates whether this PDU is going to be sent periodically, yes or no. The num field shows a numerical index for the PDU. You can double-click on the edit field to edit this PDU in this complex PDU window, where you can change many properties of this PDU, from source address to destination address to sequence number and size, and of course the periodic interval that this PDU is supposed to be sent. Maybe we can change the periodic interval to 5 seconds. Now as you can see, the detail has changed. Or you can double click on this delete field to delete this user created PDU. You can also arrange the placement of each of the fields in the PDU list by dragging the title of the field to the desired position. Please note that if you reset the simulation, the PDUs will not disappear from here. It will only disappear from the event list and the time will be reset to 0. If you want to delete a PDU from PDU list window, then you definitely need to double click here. You cannot delete it by resetting the simulation. That's it for this episode, everyone. I hope this has been informative for you, and I would like to see you in the next episode. Stay tuned. Hello and welcome to this episode of Packet Tracer. In this episode, we want to talk about creating complex PDUs. So as you know that we have simple PDUs, I have two PC configured, PC0 and PC2, with these IP addresses configured, and I can send a simple PDU, which is this one, add simple PDU from this PC to this PC, and it's just a simple ping packet from one PC to another. I can also make a complex PDU from this PC through wherever I want to. So now with the complex PDU window, I have a lot of customizations that I can do. The first thing that we can customize is the source device. Of course, we have already defined the source device, but the outgoing port, we can leave it to the default, or we can actually select more ports if there was available to this PC. The next thing that we can select is the type of application. Not only that we can ping to the other PC, not only that we can use ping or ICMP, there's other different protocols that we can use for creating a complex PDUs. So let's just stick with ping for the time being. The destination IP address, for example. For me, that's 192.168.1.2. The source IP address, if I have a few different port or interfaces with this PC, then I can also define the source IP address, but that's not really applicable for me. The time to live in the IP header, also the type of services in the IP header for quality of service, the sequence number, all of these options could be set here in the complex PDU window. There's also the simulation setting, which allows us to have a one-shot ping packet from one device to another, set the time so that it happens, for example, in 10 seconds or 20 seconds, wherever seconds that you define, or it periodically happens in an interval of 5 or 10 or 15 seconds. So maybe we can choose a 15 seconds interval. Now let's create this PDU. I don't have a sequence number. Let's use 1. And now, as you can see, the PDU is created. The way I can see that my ping was successful, if I go to user created PDU window. So in here I have the details, but it's not a good view here, so let me toggle the view. Now you can see that I have the PDU list in here with more details and a better view. As you can see, the one that I had created was the second one, and you can see the sequence number. You can see that it was set for an interval of 15 seconds, and you can see that it was successful. So a lot of the details can be seen in here, and even if I want to edit this packet, I can edit it once again and apply the changes. Or I can even delete it by double clicking this delete field. Now, as you can see, I have deleted my complex PDUs. That's it for this episode, everyone. I hope this has been informative for you, and I would like to see you in the next episode. Stay tuned. Hello and welcome to this episode of Packet Tracer. In this episode, we want to talk about editing the network and using the Cisco IOS in simulation mode. Although we know that real-time mode is the preferred mode for network configuration, we can also edit the network directly in simulation mode. So let's go to the simulation mode. As you can see here, I am in the simulation mode, and I can bring changes to the network however I want to. I can add a router, remove a router, and these changes are also possible in simulation mode. In simulation mode, whenever you're working with the iOS commands, if the command does not need the propagation of a PDU in the network, then that command will happen in real time, even though you would be in simulation mode. So let's try something. Config t interface fast ethernet 0/1, and if I enter a shutdown command, it does not need the propagation of PDUs, so it happens in real time even though I am in simulation mode. Now let's unshut it once again. As you can see, the port is turned on once again without any delay. But if a command needs the propagation of a network, like a ping command 192.168.1.1, I'm trying to ping the PC. Sorry, I need to be in the other mode, so let's go here, ping 192.168.1.1. Then you would be able to see that the time halts and you need to move or play the simulation or move forward. So let's play the simulation, and also I want to be able to see the command line as well. Now I'm playing the simulation and I also want to be able to see the command line. As you can see, the command line is also moving and showing results, but it is very slow and it is up to the time that's running in here. So it would be usually very slow in simulation mode, even though it will still show the results of the command in real time. So maybe let's make the simulation a bit faster. Now if I go here, then you would be able to see that the results of the command line is actually real time in simulation mode. As you can see, the ping was successful. So basically you already know that in simulation mode we have the ability to move forward, move backward, stop the simulation, or capture or play the simulation. Also remember that packets that are created by the CLI command line of the iOS, they will not appear here in the... That's it for this episode, everyone. I hope this has been informative for you, and I would like to see you in the next episode. Stay tuned. Hello and welcome to this episode of Packet Racer. In this episode we want to talk about time management between the real-time mode and the simulation mode. Real-time mode and simulation mode share a common master timeline. The master timeline is transparent to the user, so you cannot see it in a numerical form. The master timeline only moves forward. You cannot reset it or move backwards in time. The master timeline is always advancing when you are in real-time mode, moving at the model speed of real-time as shown in the... When you switch to the simulation mode, the master timeline pauses and falls somewhat under your control. At that point you will be running under simulation time, which can be thought as a segment of the master timeline. You can use the auto capture or play or capture and forward buttons to move forward in simulation time, which will cause the master timeline to advance accordingly. You can use the back button to view a previous network state. However, time does not actually travel backward. The master timeline will remain at its most forward state. For example, if event A occurs and then you use the back button to move backward in time to create event B, the result will not be what you expect. When you play this scenario, event B will take place after event A, even if you think that you have forced event B to occur first. Thus, it is impossible to interfere or preempt an event that has already occurred, and you should not consider using the back button for that purpose. If you clear the event list, the simulation time will restart at 0, but the master timeline will continue from the last event. When you switch back to the real-time mode, the master timeline will continue off the last event in simulation mode and move forward at a real-time speed again. If you started some event in simulation mode, then switch to the real-time mode, then that event will continue and finish in real-time mode. For example, if you created a ping packet between two devices in simulation mode, let's create a ping packet, ping 192.168.1.1. And now we will switch to real-time mode. That ping will proceed in real-time mode. Now, as you can see, the ping has already occurred. One of the powerful features of Packet Tracer is the ability to manipulate time and events on the network model. However, be aware that interpreting immediate results like viewing, switching, and routing tables while network protocols are still converging can be a complex task even in Packet Tracer. That's it for this episode, everyone. I hope this has been informative for you, and I would like to see you in the next episode. Stay tuned.